Hello everyone, my name is John Paul Dulay, and today I would like to do a demo or the fault test on the Schweitzer relay that I have here in the lab. And before I dive into that, let me talk about the configuration that I have here. So what we have here is the RTDS machine, or also known as the real-time digital simulator, in which the Schweitzer relay is hooked up onto it in a closed loop configuration. So how does that work is right now this machine is simulating a power system, and it is sending signals into the relay via its GTAO cards, which is located at the back of the machine. These are the GTAO cards, and right now it is sending signals through to the Schweitzer relays through these wires. And what these signals represents are the three-phase primary currents on my power system, and they're being delivered into this ribbon cable, which in turn it goes into the processing module located behind the front panel of this relay. And in this demo I am using 2 units of the Schweitzer 311L Line Current Differential Protection scheme, protection relays. And let's go into the back of the one of the relays over here. And these are the output contacts of the relays, which runs back to the RTDS into these banana cables into the low voltage digital interface of the machine. And this pretty much represents the breaker circuit of my power system. And now let's dive into the monitor. Over here is the RSCAD software that comes with the RTDS technologies. And in this draft module I have built a simple power system complete with a generator, transformer, current transformer, a breaker, my transmission lines, and a load at the end. And going into the runtime module, which it is tasked to simulate that power system, I have replicated the power system earlier and put them here in a more compact and simplified way. And going into it, in this demo I have named the left side of the transmission line as the local side, and the right side of the transmission line as the remote side. So over here I have implemented the line current differential protection scheme to protect this transmission line from internal faults. So right now the RTDS machine is simulating a primary current running through this transmission line on the local side, and right now it's reading 499.1 amps. Right now it's reading kiloamps, so we just have to move 3 decimal places to convert it into amps. And I can verify this number through my local relay over here, which is reading the same number that I have in the runtime module. And I can even verify it further through the accelerator quickset HMI, reading the same number as we have over here. And by the way, my computer, which has the HMI, is serially connected to my Schweitzer relays on this port and this local relay. Alright, so going further into my runtime module, this is the 3-phase line-to-line voltage signals being simulated by the machine, and this is the 3-phase primary currents also being read by the machine. And right now we are in a normal condition of the power system, so you can see that the 3-phase signals are about 120 degrees out of phase from each other. And this is the local side, and you could see on the remote side of the transmission line the line-to-line voltage signals and the primary current signals are also the same with the local side. And now let's go ahead and induce a 3-phase line to ground fault into this transmission line, and let's see what will happen to the relays. Alright, so looking into the relays, my local relay has picked up the fault signal, and how I could tell that how I could tell that it's because the relay has turned on its LED lights, indicating that the relay has picked up a fault. And you could see also the LED lights here on the remote side of the relay, and you can see it's three-phase, meaning there was a three-phase fault that had happened. Looking here in the local relay. Alright, so let's go back again to our runtime module and let's view the signals being read. So here is the local primary current side of the transmission line, and as you can see, from normal condition and into the fault condition, the primary currents has spiked up to more than 2 kiloamps, and the power system has sustained the fault for about 2 cycles, and then the relay was it took the relay 2 cycles for it to pick up the fault signal, and then send a signal to the breaker to open it, and thus interrupting the current, the primary currents to the transmission line. And as you can see here in the line-to-line voltage signals from pre-fault, fault, and to post-fault when the breaker was opened. That's the local side of the transmission line. And going into the remote side, you can see the voltage line-to-line ground, voltage line-to-line, three-phase. This is how it behaved, and this is the local primary remote side currents. And alright, so that pretty much conclude my demo of the fault test on the Schweitzer relays.